Okay. Hello all. We belong to the team Tech Croods, which composed of 5 members: Lakshya, Praveen, myself, Shamita, and Vignesh. Next slide. This is the overview of our content. Next slide. Introduction. Okay. To start with, we live in a world of sensors. The smart device industries allow developers and designers to embed different sensors in small electronic devices. Sensors are to enhance the usability of these devices and improve the quality of experience through data collection. The first generation of sensors is Bell, which rings on vibration of string. It has two parts: detection and processing. When it detects vibration, it starts ringing for a particular period of time. Next, to say about sensors, uh, next slide, Pa. There are numerous definitions, but generally, sensors are the devices or machines used to detect the presence of any physical object in the environment. The device is mostly used with other electronic devices. It is the heart of a measurement system. It is also called as detectors, which receives and responds to a signal. Next, motion sensor. Motion sensor, which is also called as a motion detectors. Motion is generally a change in position of object with respect to time. It is defined as sensing system used to detect motion. Next, we see about numerous types of sensors present inside our mobile phones. Some of them are accelerometer, gyroscope, magnetometer, proximity sensor, light sensor, barometer and thermometer sensor, speedometer and heart rate monitor sensor, fingerprint sensor. Let us see them in detail. Uh, the next will be continued by Praveen.
Accelerometer. An accelerometer is a device that measures the vibration or acceleration of motion of a structure. Accelerometer in mobile phones are used to detect the orientation of the phone. It is measured in terms of g-force. Next slide. Gyroscope. Accelerometer is good at measuring the displacement of object. However, it is inaccurate to measure the spin moment of the device, which is an easy thing of gyroscope. It is a device for measuring or maintaining orientation based on the principles of angular momentum. Mechanically, a gyroscope is a spinning wheel or device or disc in which axle is free to assume any orientation. Next slide. Magnetometer. It is a measuring instrument used to measure the strength and perhaps the direction of magnetic fields. Accelerometer and gyroscope are able to detect the direction of movement. However, the direction is a relative direction. It obeys the coordinate system that a smartphone uses. Sometimes different smartphones need to synchronize their directions. Therefore, a magnetometer is needed to get an absolute direction. That is, the direction obeys the coordinate system of Earth. Next slide. Proximity sensor. Proximity sensor is comprised of an infrared LED and IR light detector. It is placed near the earpiece of a phone, and for a good reason. When you place the handset up to your ear, the sensor lets the system know that you are most probably in a call and the screen has to be turned off. The sensor works by shining a beam of infrared light which is invisible to humans, which is reflected from a nearby object and picked up by the IR detector. The following sensors will be explained by Shamita.
Hello, light sensor. A light sensor generates an output signal indicating the intensity of the light by measuring the radiant energy that exists in a very narrow range of frequencies, basically called light, and it actually ranges in the frequency from the infrared to the visible up to ultraviolet light spectrum. It measures how the ambient light is in mobile phones. The phone software uses this data to adjust the display's brightness is pumped up, and when it is dark, the display is dimmed down. Next. Barometer sensor. A barometer sensor is a sensor which measures the atmospheric pressure. Data measured by it is used to determine how high the device is above the sea level. which in turn results in the improved GPS accuracy. The barometer assists the GPS chip inside the device to get a faster look by instantly delivering the altitude data. Additionally, the barometer can be utilized to provide floors climbed information to a phone's health app. With the advent of more accurate indoor navigation, the barometer can assist in determining what floor a user is on within an airport, for an example. On related note, the Motorola Zoom and the Samsung Galaxy Nexus were among the first Android devices to feature the sensor. Next. Thermometer sensor. A thermometer sensor is used for measuring the ambient temperature. However, there is a thermometer in pretty much any smartphone, and some handsets might have more than one of them. The difference is that they are used to monitor the temperature inside the device and its battery. If a component is detected to be overheating, the system shuts itself down to prevent the damage. And speaking to Galaxy S4, it pioneered the use of an air humidity sensor in a smartphone. Data provided by it was used in the S-Health application to tell whether or not the user was in their comfort zone, one with optimal air temperature and humidity. Next. Fingerprint sensor. Fingerprint sensor is one kind of sensor which is used in a fingerprint detection device which is mainly inbuilt in it. Nowadays, almost all the smartphones have built-in fingerprint sensor. Fingerprint scanners are most often used as an extra layer of security as a substitute for a lock screen password. Fingerprint sensing technology has also moved on a lot from its earlier iterations, becoming faster and more accurate at capturing your fingerprints. The basic principle of working of fingerprint sensors lies mainly behind the process in which the sensor scans the fingerprint and generates a pattern and stores it in the system as two-dimensional or three-dimensional data. So when a user places his or her thumb on the device, the system will create a pattern and compare it with the stored data. Next will be continued by Vignesh.
Types of fingerprint sensor: optical fingerprint sensor, capacitive fingerprint sensor, ultrasonic fingerprint sensor. First, optical fingerprint sensor is the purest form of sensor out there. The device emits light on the finger after placed on it and then capture the data into 2D image and save it in the system. Capacitive fingerprint sensor depends upon the series of capacitor plates to obtain a fingerprint. For these capacitors, the fingerprint acts like hold and valleys. With the help of electricity stored in the capacitor, it maps out the areas of fingerprint and thus save it in the system. Ultrasonic fingerprint sensor. It emits ultrasonic waves to map out the areas of print in three dimensions and save it as a 3D image, and they are thus making it the most accurate of all. It is so precise that it can also capture the skin pores of an individual. Next, heartbeat sensor. It uses our phone's camera instead of a separate heart rate sensor. As your heart beats, the capillaries in your fingers contract and dilate, causing a change in the way they reflect light. This process is called photoplethysmography. If you shine a bright light like your phone's LED flash on your index, its thin skin becomes slightly transparent, making the capillaries and their pulsing detectable. Now, if you have a camera nearby, you can take a video of your fingerprint and use a smart algorithm to distinguish the pulses and hence calculate the heart rate. It is very accurate. Advantage of sensor. Sensor can be accessed through a centralized monitor. Sensor networks allow a system to be extended from one with basic function to one that can receive and act on data about the environment it operates in. Sensors like PIR detectors are relatively cheap if you're using wired versions of it. It can accommodate new devices at any time. It avoids a lot of wiring. It is flexible to go through physical partitions. Next. Disadvantages. A sensor that we wouldn't expect to find on a smartphone is one capable of detecting harmful radiation. Yet there is a phone that supports it on the Sharp Pantone 5, which is released only in Japan. It features a dedicated button which launches an app used to measure the current radiation level in the area. We can't control the propagation of waves, comparatively low speed of communication, yet distracted by various elements like Bluetooth, still costly at lots. Next will be continued by Lakshya.
Next comes the gestures, in which the gesture recognition is commonly used by all the people nowadays in their smartphones, which enables us to interface with the machine and interact naturally without any mechanical device intervention. So what the phone does is it senses the gestures made by the humans and performs accordingly. Gesture recognition can be conducted with techniques like computer vision and image processing. For example, we also point in front of a computer screen to make the cursor move accordingly. There are also some Android gestures to be noted, in which they are designed so that a different skin can be layered on top of the default Google layout. This is fine up to a point, but it can slow updates down and it can also change the available gestures sometimes. For that reason, we are supposed to check the user manual for our device most of the time. There are some gestures which are pretty much universal on Android devices nowadays. Some of the gestures pointed here are tapping, double tapping, dragging, clicking, which are used commonly by all of us. So some gestures to be noted down is the double tap, which allows us to zoom a photo on a screen, and long tap can allow us to perform actions with respect to icons like removing an icon or uninstalling the icon. And the finger pinch or squeeze allows us to zoom in or zoom out according to our need. And scrolls, drags, and swipes can be performed according to the page that we are present in the application. And double finger swipe down, spacebar trick are also the Android gestures available. There are some Apple gestures to be noted, in which swiping up in an iPhone allows us to direct to the home screen of the iPhone, and swiping left or right allows us to cycle between the opened application present in our iPhone. And also shaking any iPhone will allow us to undo the thing that we have done before. Swiping down from the middle of the screen or from the center of the screen allows us to direct to the web search widget. Short finger trick is also present in iPhones, in which we don't need to make our finger to reach to the top of the phone to swipe the notifications. Instead, we can swipe down from about 1 inch from the bottom of the screen. There are also some benefits to be noted, in which the gestures can replace the keypad of a phone and it can navigate into a virtual environment. We can pick up and manipulate a virtual object without even having contact with the object. We can interact with the 3D world. No physical contact is required with the computer. We can communicate at a distance. No training is required for performing these Android gestures. They are simple and easy to implement. The system is successful in recognizing static and dynamic gestures, and it could be applied on a mobile remote control. There are also some disadvantages, in which instead of our fingers, if there are irrelevant object making interaction, it will become a wrong object interaction. And also performance recognition algorithm decreases when the distance is far away than the 1.5 meters between user and the object like camera. System limitation restrictions are also there, such that our arm should be vertical, palm should be facing the camera, and finger color must be the basic color when it comes to Android gestures. And also ambient light sometimes affects the color detection threshold. These are the disadvantages. Thank you.